Okay, so this is the last section that we're going to do in chapter 10.6. In chapter 10. Next week we'll be going on to some review from the beginning of the book, and we will then use that information to go on to chapter 11 and talk about some statistics and studying data. And that, I think that will be the last thing that we do going into the end of the school year. So, I could be wrong about that. Hang on. Yeah, nope. That'll take us to the end of the school year. So, on 10.6, we're going to discuss the binomial theorem, and there's two processes. One that's kind of a basic building block kind of method, and then we're going to talk about the binomial theorem, which looks really complicated, but after you work through it once or twice, you'll understand how it works. So Pascal's triangle is something that was thought up years and years and years ago, but we can use it to help expand a polynomial with multiple identical terms. So you'll have an a plus a b to some power. I mean, and this could be 50, and we can use this to figure out that entire polynomial from the first term to the 51st term. So what you're going to do, and you have your notes which kind of build this for you, but what they did for Pascal's triangle was they started with one term. When you have something to the 0 power, so let's just make this 0, it's always 1. When you have something to the first power, well, if we do that, it will have two terms, and each of their coefficients will be 1. It'll just be 1a plus 1b. If we took a plus b times itself, or so a plus b times a plus b, and we FOILed that, we would get a squared plus 2ab plus b squared. So we'd get 1, 2, and 1 as the coefficients for that term. If you then took a plus b and you cube it, you add another term there, they found out that we can get these coefficients by expanding this triangle down. And all you do is you take two terms above, like if this was our belly button, number 2, then we take our left shoulder and our right shoulder and we add them together. So you're always going to start with a 1. All of these start with a 1, because when we multiply a squared times a, it'll be a cubed and it'll have a coefficient of 1. So we have a 1, and then we figure out what our belly button is going to be. 1 plus 2 is going to be 3. 2 plus 1 is going to be 3. And then we'll end again with a 1. And we can keep doing this. So a plus b to the 4th, start with a 1, figure out what your belly button is. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And we have to end with a 1. So we keep expanding this triangle out far as we need to go. So if we do the 5th, for example, start with a 1. 1 plus 4 is 5. 4 plus 6 will be 10. 6 plus 4 is 10. 4 plus 1 is 5. And 1. Okay, so that was for the 5th. And these are the coefficients of these terms. So you would start with a, let's see, a to the single power here. So this would be a plus b to the 6th. This one here would start out with your a to the 6th. This term will have a 5th, that'll have a 4th, that'll have a 3, that'll have a 2, that'll have a 1, and the a here will have a 0. Okay, so 6, 15, 20, 15, 6, and 1 when I add all these things together. So what does this mean? Well, let's just take, let's just do this 6th power here. Okay, so you're going to have a and you're going to have b. This is going to start with a to the 6th. Then you're going to have plus 6, and all the a powers, the a's are going to go down, and the b's, the exponents, are going to increase. So this is like a to the 6th, b to the 0. This is a to the 5th, b, plus 15, a goes down to the 4th, and b will be squared, plus 20, a to the 3rd, b cubed, plus, I'm on the 15 now, a squared, b to the 4th, plus 6, a goes down to 1, b goes up to 5, and I'm up to the 1, 1, b to the 6th, and you could say a to the 0, but that's what is going to be your answer. So if you did all that terrible multiplication that would lead you to this, that would be your expanded polynomial. We take the coefficient, and then the a exponents go from 6 down to 0, a to the 0, and the b's start at b to the 0 and increase 1, 2, 3, 4, 5, and 6. That would be how you would expand this polynomial. So you will be asked to do one. How this changes is, what if we're asked to expand, let's see, in our notes, it says let's expand 2a minus b to the 6th. So that changes a little bit. 2a instead of regular a, and minus b. What will that do for us? Okay, so we have to consider this process with the 2 and with the minus 1. So it's going to be 2a to the 6th power times negative b to the 0 power plus, and you're going to do this for each term. This is the 5th, negative b is to the 1st, plus 2a to the 4th, negative b squared, plus 2a to the 3rd, negative b, where are we at, 3, plus 2a to the 4th, negative b, b is going, nope, sorry, a is going down, this is a squared, this is a 4th, plus 2a to the 1st, negative b to the 5th, oh, I almost had it, plus 2a to the 0 and negative b, oh, sorry, lost you there. I hope you can see that. Negative b to the 6th. Okay. Might have to rewrite that side term. But you'll take each piece, what is it, and you'll give it, so this is to the 6th, 5th, 4th, 3rd, squared, 1, and 0. The b's, I get my negative b, 0, 1, 2, 3, 4, 5, and 6. And then you have to simplify them. So it is a little lengthy still, but it saves you a whole bunch of time instead of trying to have to multiply out all those polynomials. Alright, so what is 2a to the 6th? Well, 2 to the 6th power will be 64, a to the 6th, negative b to the 0 is just 1, so that term is done. 2a to the 5th, 2 to the 5th will be 32, a to the 5th is 5, negative b to the 1st power, well, that's going to be b, and let's just make this a minus. Okay, minus 32, a to the 5th b, plus 2 to the 4th is 16, a to the 4th, minus b squared. The negative will cancel because that's an even power, so it'll be b squared. Alright, now we're on our thirds. Plus 2/3 is 8, a cubed, b cubed, and the negative 1 cubed means that this has to be minus. Okay. Right, we're under this term here. 2 squared is 4, a squared is a squared, negative b to the 4th, the negative will cancel out, and we're just left with b to the 4th. Well, I almost wrote my plus, but I bet you it's going to be negative because it seems to alternate every time, which is what happens with our negative 1 to the odd powers. So it's going to end up being minus, which we'll talk about in a minute. 2a minus b to the 5th will be negative b to the 5th. And then plus 2a to the 0 is just a 1, and it's minus b to the 6th. So the negative cancels, and it's b to the 6th. So this is your answer. a couple of things to know about Pascal's triangle. So if you have n, these were our exponents, were our n's. N was 0, we had one term. N was 1, we had two terms. N was 2, we had, because this was a plus b to the n that I changed. So when it's 2, we have 3 terms. So every time for Pascal's triangle, there are one more than n number of terms. N is always the exponent of the first and last term. So we did the sixth. This was 64a to the sixth and b to the sixth. That has to be true. Also, each term's exponents will add to that n. So we had a 6, we had a 5 and a 1, if you like. Hold on, where are we at? So we had a 6, we had a 5 and a 1, which is 6. We have a 4 and a 2, which is 6. We have a 3 and a 3, which is 6. 2 and 4 is 6. 1 and 5 is 6, and 6 is 6. Okay, so that is going to work. That's all you have to do to use Pascal's triangle. You write each term to the correct power, which is given by this n, and then you have to simplify. Okay? Then we're going to talk about the binomial theorem. Okay, so I did a little setup for us. So the binomial theorem uses some shorthand things that we can do to get to an expanded polynomial, and more importantly, if we just need a specific term of that polynomial. So something to remember, we use factorial in this method. So remember that n factorial takes n and then the next number down, keep multiplying all those numbers until you get to 1. It's the answer of that. So 5 factorial is 5 times 4 times 3 times 2 times 1, or 5 times 4 is 20, times 3 times 2 times 1 is 6, so 5 factorial is 120. Okay, so the way to use the binomial theorem to expand a plus b to the nth, which is exactly what we did in Pascal's method, is you're going to have a sum, so we're going to be adding terms, okay, and that's what we do when we are writing a polynomial. It's terms added together. K will always be 0, and you're going to go up to the n. So if this is a plus b to the 4th, you would go from 0 to 4, and our equation here will be n factorial over n minus k factorial times k factorial. That's going to be the coefficient of each term, and then you're going to have whatever your a is to the n minus k, and then b to the kth power. Okay, so what we're going to keep doing is we're going to increase this k as we proceed through. Okay? All right. So let's look at an example. Okay, so I'm going to use the one that we did in the notes, which is 2a plus 4b to the 4th. And what we need to do then is fill this in. Okay, so what we're, the summation that we're doing will be just this up here. Actually, let's just leave it off and use that as our example. Okay, so n is 4. N is 4. We're going to use this as a and that as b. Okay, so for our first term, we get 4 factorial over 4 minus 0 factorial, 0 factorial. Okay, so then we have to do 2a instead of just a, n minus k, or 4 minus 0, and b, 4b instead of just b, to the k, which is 0. That would be our first term. Okay, so this looks a little bit scary, but it's not too bad. Okay, so what happens here is that this is 4 factorial over 4 minus 0, or 4 factorial, and 0 factorial is actually an identity. It's just 1, so we can replace that with 1. And 2a here will be to the 4th power. 4b to the 0 power, that's just 1. Alright, so 4 factorial over 4 factorial is 4 times 3 times 2 times 1, 4 times 3 times 2 times 1. Well, this is all product, so you can either multiply it out and say, alright, this is 24 over 24 over, or 24 over 24, which all of this cancels because it's all multiplication. So we're actually here, this term is just left with 2a to the 4th. But the process allows us to find those more difficult terms in the middle. So our first term here is just 2a to the 4th. Let's do the second term. The second term will be when we have 4 as n. So 4 factorial, and k goes up to 1. Okay, so k is going to succeed through the process. So now we have 4 minus 1 and 1 factorial. And then we have 2a to the 4 minus 1 and 4b to the first. So let's simplify this part. 4 factorial will be 4 times 3 times 2 times 1. 4 minus 1 factorial, that's 3 factorial. So 3 times 2 times 1, and 1 factorial is just 1. 2a will be to the 3rd, and 4b will be to the 1st power, or just 4b. Alright, we gotta keep going here. So what cancels here? My 3's, my 2's, and my 1's are all gone. So this is really 4 times 2 cubed is 8, a cubed also times 4b. Okay, so that's getting a little more complex, but we'll get there. Okay, next term, we're going to run out of space here, so I may have to get a little creative. So we've done 1, we need to do 2. So 4 factorial over 4 minus 2 factorial and 2 factorial. Can't quite see my factorial there. But then 2a to the 4 minus 2 and 4b to the 2nd power. That's my next one. Alright, so 4 factorial is 4 times 3 times 2 times 1. 4 minus 2 factorial is 2 times 1. 2 factorial is 2 times 1 times 2a. 4 minus 2 is squared. 4b is squared. Okay? What cancels here? I have 2 times 2 on the bottom, so it's really just a 1. So I have 3 times 2 times 1, or 6, as that coefficient. 2 squared is 4. A squared is a squared. 4 squared will be 16. B squared. And then we'll have to keep going. Alright? But I think you get the idea, maybe? So let's just simplify and say that these are the first 3 terms. Okay? So only first 3 terms, just so you know it's not a complete evaluation of the polynomial. So here we have 2a to the 4th. So 2 to the 4th, a to the 4th, we'll end up having 16a to the 4th as that first term. Then we have 4 times 8 is 32. 32 times 4, and I don't have my calculator in here with me, so let me pull up my calculator. 32, maybe. Clear? Nope, that won't let me. Hang on. You may already have it, but I can't hear you from where I am. So, come on, guys. 32 times 4 should be 130. Oh, 128. All right. So let's just say plus 32 times 4 a cubed b, which we get to be 128 a cubed b. Okay, and then this third one will be 6 times 4, 24 times 16. Oh, I should not have put that in parentheses. Sorry for that confusion. this was 4 squared, so it was 16 and then b squared. A squared, b squared. So I need to know 24 times 16, that is 384. A squared, b squared, and it'll keep going because I have a power of 4 here, so I have 2 more terms technically that we did not finish evaluating, but this process continues. Okay? Hopefully, okay. So that is kind of a big hot mess. But the point is, oftentimes you're only going to be asked to find a specific term where you know this is the polynomial, this is what's going on, and I need to know what happens in the 5th term because that will answer my scientific question. So example 3 in our notes that we have is find the 5th term of x minus 4 to the 9th. So we can use this and just find that 5th term. Okay, so what can we do here? We know here let's see, this was the, when we had the first term, we were using 0. So the 5th term will be when we use 0, 1, 2, 3, 4. We want to use 4 for k and 9 for n. And we're going to use x and minus 4 as our a and b. So all we have to do is say n factorial, 9 factorial over 9 minus 4 factorial, 4 factorial. A is x, so that will be to the 9 minus 4, or the n minus k. And then b is negative 4, and that is to the kth power, so that was 4. So we just have to do that piece. So this is the same as, let's see, I'll just write it out, 9, 8, 7, 6, 5, 4, 3, 2, and 1 over 9 minus 4 is 5. So 5, 4, 3, 2, 1, and 4, 3, 2, 1. So that's all my factorials. It'll be x to the 5th, and then negative 4 to the 4th is 4 to the 4th is, let's see, 4 cubed is 64, so I think that's 256. Negative 1 to the 4th is positive, so we don't have to worry about the negative. So 4, 2, 3, 4, yeah, 256. Okay, so we have to simplify this. So my 4 factorial cancels, that's nice and easy. What else can I cancel to make this math simpler for me? I've got 5s that'll cancel. I've got a 3 and a 2 that'll cancel with this 6. I can cancel this 4 and make this a 2. Alright, well that makes it a little easier. So this is 9 times 2 times 7 times 256 x to the 5th. Alright, so let's do that. 9 times 2 times 7, oops, that's a 4, times 256 is 32,256 x to the 5th. Oops, sorry, slid that. Okay, so yes, 9 times 2 times 7 times 256 is correct. 32,256 x to the 5th is just that 5th term, which is all they're asking me for. Okay, so for this section, we are not going to spend too much time on it. So I am going to ask you to do numbers, just the homework. We're going to skip the worksheet for this section. Excuse me. So it should be, let's do 16, 20, 28, and yeah, 16, 20, 28. And we'll just do those 3, okay? those are the ones that I want you to do for the homework, because you can submit the homework, and then next week we will be starting some review, which is in chapter 0, the very beginning of the book. Please note, I will not accept just the answer. I need to see your work written out for this. There's only 3 problems, so I need all work shown for these 3 problems. All right, and this will be the last assignment for this week, so get caught up on everything else, and we'll start fresh next week. Thanks, guys.